This is the roulette wheel circuit. In this circuit, the LEDs are arranged in a circle so that when they light up, one after another, a spinning illusion is created. Some of the components used in this circuit include the 2N3906 transistor, the 555 timer, the 4017 decade counter, and both polarized and non-polarized capacitors. In this circuit, the 555 is in astable mode, meaning that the output continually switches from high to low. These pulses are what causes the LEDs to spin. To start the roulette wheel, the circuit must be completed by either having these two touch wires come into contact or by pinching them like this so that I complete the circuit. Once the circuit has been completed, this polarized capacitor begins to charge and current is supplied to the base of the transistor here. The current can now flow through these resistors into pins 7, 6, 2, and these resistors and these non-polarized capacitors to ground. When the current flows to pin 2 via 6, the voltage is compared to 1/3 of the original voltage, 9 volts. If it is lower than 1/3 of the 9 volts, so 3 volts, pin 2 is triggered, setting it to high. Setting pin 2 high will also set pin 3 to high, which is connected to pin 14 of the 4017. This will make the counter in the 4017 advance by 1. Right now, the LED is connected to pin 2 is lit because pin 2 turns high when the count is 1. Each pulse sent by the 555 will cause the counter of the 4017 to advance, which will simultaneously turn off the lit LED and turn on the LED connected to the pin associated with the next number. The 4017 will stop counting at 9, which is this LED, and reset to 0, this LED, because it is the decade counter and it starts at 0. These two non-polarized capacitors control the speed at which the wheel spins. If the capacitance is increased, this LED spins slower, and vice versa. When I let go of the touch wires, the circuit is no longer complete. However, the wheel keeps spinning because this polarized capacitor is discharging into the base of the transistor, thus still supplying power to the trigger pin so that the 555 can pulse. The 555 pulses at a slower rate as current slows since the capacitor is losing charge, until finally it has no more charge, causing the 555 to stop pulsing. This stops the counter of the 4017, causing the wheel to stop, because this capacitor is what keeps the wheel spinning after the touch wires are released. The capacitance of this capacitor determines how long it takes for the wheel to keep spinning.